Hello everyone! Today we'll be doing the Fashion Twins activity. So, let's take a look at Dana's winter clothes. She has a total of 7 articles of clothing, and she only has 2 colors, green or plum. Dana only likes to wear the same color for pants and jacket. In other words, she likes to dress uniformly. So, she has 2 green jackets, 3 plum jackets, a green pair of pants, and a plum pair of pants. And she only likes to wear the plum pants with one of the 3 plum jackets, and she only likes to wear the green pants with one of the 2 green jackets. She does not like to wear the plum pants with a green jacket or the green pants with a plum jacket. So, out of all the possible combinations of jacket and pants, what percentage are okay for Dana to wear? In order to figure this out, let's draw a tree diagram. So, let's start with our jackets. We have 2 green jackets and 3 plum jackets. So, we're going to draw a branch representing each of our jackets, as such. Then, we can either choose the green pants or the plum pants. So, we're going to draw a branch coming out from each jacket, representing each pair of pants that we can choose, as such. So, let's use the letter G to represent green, and the letter P to represent plum. So, as we can see, that not all of these combinations are okay. They're only okay if we have the same letter. So, GG or PP. So, the combinations that are okay are in bold. So, let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total combinations. And this should make sense because we have 5 jackets and 2 pairs of pants. So 5 times 2 is 10. But let's see how many combinations are acceptable for Dana. We have 1, 2, 3, 4, 5. So we have 5 out of the 10 possible combinations that are okay for Dana. As a percentage, this would be 50%. So 50% of the possible combinations are okay for Dana. Another way we can solve this problem is by using a table. So, in this table, we have the jackets to the left. We have the 3 plum jackets and the 2 green jackets. And then on the top, we have the 1 plum pants and the 1 green pants. So, in order to find the total number of combinations, we multiply the number on the side by the number on the top. So, for example, if we're looking at the combinations with a plum jacket and a plum pants, we multiply 3 by 1. So 3 by 1 is 3. So that means we have 3 total possible combinations of the plum jackets with the plum pants. And then we're going to do this with each box. Then we add up all of our total possible combinations. So 3 plus 2 plus 3 plus 2, and we get 10. But only the ones in bold are acceptable, right? Because we can only have plum jackets with plum pants or green jackets with green pants. So if we add those up, we get 3 plus 2, which is 5. So we have 5 acceptable possible combinations out of a total of 10, which is the same answer as we got before when we used the tree diagram. So now Dana wants to buy one more item, either a new pair of pants or a new jacket of any color, including possibly colors that she doesn't already wear. But she wants to increase the number of outfits that she could wear as much as possible. In other words, she wants to increase the number of possible combinations between pants and jacket of the same color as much as possible. So, which type of clothing and which tone should she buy if she wants to increase her options as much as possible? Let's also try to figure this out if she wants to buy 2 new items of clothing or 4 new items of clothing. In order to try to figure this out, let's look back at our tree diagram from before. So, if we look back at this tree diagram, we can see that we have 2 possible green outfits and 3 possible plum outfits that Dana could wear. So, since we have more plum outfits, we know that by buying a new plum item would increase her chances as much as possible. So, we know that she can either buy a new plum jacket or a new pair of plum pants. Let's draw a tree diagram to see how many acceptable combinations we would have if Dana bought 1 new plum jacket. First, we'll start by drawing 6 branches, representing the original 5 jackets that we had, plus the new plum jacket. Then, she can either choose to wear the green pants or the plum pants, so we'll draw 2 branches coming out of each branch for the jacket, representing the 2 options. once we do that, we can see that only a few of these options are acceptable for Dana. We have 2 acceptable green outfits and 4 acceptable plum outfits. So we have a total of 6 outfits that Dana could wear when we buy 1 new plum jacket. Now, let's draw a tree diagram to see how many outfits we could get if Dana were to get 1 new plum pants. We'll start with the 5 jackets. Then, she can either choose to wear her green pants, her old plum pants, or her new plum pants. So, we'll draw branches coming out from each branch for the jackets, representing these decisions. Now, when we do this, we can see that when she buys 1 new plum pants, she has 2 green outfits and 6 plum outfits. So a total of 8 possible outfits. So, as we can see, we have 6 total outfits that Dana could wear when she buys 1 new plum jacket, but 8 total possible outfits that she could wear when she buys 1 new pair of plum pants. So, if she wanted to increase her total possible combinations, she should buy 1 new plum pants. Let's try to solve the problem by using a table. So, if Dana were to buy 1 plum jacket, she would have a total of 4 plum jackets. And if she were to multiply 4 by 1, we'd get 4. And then we can go ahead and ignore these boxes because she wouldn't wear these outfits anyway, because they're 2 different colors. And then we can multiply 2 by 1 to find the total number of combinations that she would have in this box. So, green outfits. And then we would get a total of 6, like we did before. Then, if she were to buy 1 new pair of plum pants, she would have 3 plum jackets, but 2 pairs of plum pants, and 3 times 2 is 6, so she would have a total of 6 plum outfits. And same thing with the green outfits. She would still have 2 green outfits. So, we would get a total of 8 acceptable outfits for Dana, if she were to buy 1 new pair of plum pants, which is the same thing as we got before. So, this just shows that if she were to buy 1 new pair of plum pants, she would have more possible combinations for outfits. Now, let's use the table to see how many new outfits Dana could get if she were to buy 2 new items of clothing. Since we know that buying more plum items of clothing would give her the most options, we can either buy new plum pants or new plum jackets. So, she can either buy 2 new plum pants, 1 new plum pants, or 1 new jacket, because we already know that if she were to buy 1 new pair of plum pants, that would just give her the most options. So, we have 3 plum jackets in this box and 3 plum pants, and if we multiply to get them together, we get 9. And then we still get 2 in this box because we're not changing the number of green jackets or the green pants. So, 9 plus 2 is 11, so we get a total of 11 acceptable outfits for Dana. If she were to buy 1 new plum jacket and 1 new pair of plum pants, we'd get 4 plum jackets and 2 pairs of plum pants. So that would be a total of 8 combinations between jackets and pants. And we still have 2 possible combinations when she has 2 green jackets and 1 green pants. So 8 plus 2 is 10. So we have a total of 10 possible combinations that Dana could wear if she were to buy 1 new plum jacket and 1 new pair of plum pants. So, since we have more options, we have 11 options when she buys 2 new pairs of plum pants, she should buy 2 new pairs of plum pants if she were to buy 2 new articles of clothing, since 11 is greater than 10. Before jumping straight into seeing which items she should get if she were to buy 4 new items of clothing, let's look at what happens if she were to only buy 3 new items. Something interesting happens here. If she were to stick with just buying new plum pants, we would get a total of 12 plum outfits, because we would have 4 plum pants multiplied by 3 plum jackets. And then if we add this to 2, we get a total of 14 possible outfits that Dana could wear. However, if she were to buy 2 plum pants and 1 new plum jacket, we're also multiplying by 3 by 12, because we have a total of 4 plum jackets and a total of 3 plum pants, giving us the same total, 14. So, in either case, we're maximizing the total number of possible combinations, no matter if we buy 3 new plum pants or 2 new plum pants and a new plum jacket. We can move on to see how many possible combinations Dana would get if she were to buy 4 new items of clothing. If she were to only buy 4 new plum pants, we would get a total of 5 plum pants and 3 plum jackets. And 5 times 3 is 15, so she would have a total of 15 new plum outfits. And then if we add that with 2, we'd get a total of 17 possible outfits. However, if she were to buy 3 new plum pants and 1 new plum jacket, she would get 4 total plum pants and 4 total plum jackets. So 4 times 4 is 16. So we had 16 total possible plum outfits. And then we add that with the total possible green outfits, we'd get a total of 18 possible outfits. This shows that if she were to buy 4 new items, she could maximize her number of combinations by buying 1 new plum jacket and 3 new plum pants. Dana's sister, Gina, has exactly the same clothes, but she only likes to wear the different colors instead of the same colors. So for example, she only likes to wear the green jackets with the plum pants, or the green pants with the plum jackets. So now let's redo parts A and B with Gina's preferences. Since Gina has the same clothes, we're going to draw the same G diagram from before. So the same 5 jackets and the same 2 pairs of pants. Then we look at the pairs. Gina only likes the pairs that are opposite, so only G and P or P and G. As we can see, we have 5 pairs that are different. We have 2 GP and 3 PG. So there's a total of 5 out of 10 outfits that are okay for Gina, so 50%. This should make sense because 10 minus the 5 matching pairs that we had before is equal to 5. And since we're looking at the opposite pairs, and we have a total of 10 pairs, then the rest of those pairs must be opposites. Let's move on to part B with Gina's case. Since we're doing different pairs instead of matching pairs, it is as obvious as which color we should buy. So let's try all of our options. 1 new plum jacket, 1 new pair of plum pants, 1 new green jacket, and 1 new pair of green pants. Let's start with 1 new plum jacket. If we were to buy a new plum jacket, we start with 6 branches for the jackets. We still have 2 pairs of pants, so we'll have 2 branches coming out from each branch of the jackets. As we can see, there's a total of 6 combinations for Gina when she buys 1 new plum jacket. Now let's see what happens if she were to buy 1 new pair of plum pants. We start with 5 jackets, then we have 3 options for the pants. As we can see, there's a total of 7 options for Gina if she were to buy plum pants. However, I think we can still do a little bit better. So let's see what happens if we were to buy 1 green jacket or 1 new pair of green pants. So if she were to buy 1 new green jacket, we would have 6 total jackets, including the 1 new green jacket. Then we would still have the same two pairs of pants that we originally have. As we can see, now there are 6 total combinations that Gina could wear. Now let's see what happens if she were to buy 1 new green pair of pants instead. We would have the same 5 original jackets, then we would have 3 options for the pants. So we draw 3 branches coming out of each branch of the jackets. As we can see, we have a total of 8 possible combinations if Gina were to buy 1 new pair of green pants. So if she were to increase her number of outfits as much as possible, then she should buy 1 new green pair of pants. Since we figured out that if Gina wanted to maximize her number of combinations, if she were to buy only 1 item by buying the green pants, she should buy at least 1 green pair of pants in order to increase her number of combinations as much as possible if she could buy 2 new items. Since we know that at least one of these must be green pants, let's check what the second item could be to increase the number of combinations as much as possible if she could buy a second item. Let's start with another pair of green pants. If she were to buy another pair of green pants along with the first pair that she bought and the original pair that she had, she would have a total of 3 green pants. So we multiply 3 by the number of plum jackets to get a total of 9 outfits with a plum jacket and green pants. And we don't care about these boxes because those are when the pants and the jacket are matching color. Then we multiply the 1 plum pants that we have by the 2 green jackets that we have to get 2. And then we add these together, so 9 plus 2 gives us 11. So if she were to buy 2 new green pants, then she would have a total of 11 new outfits. Then we do the same thing if she were to buy 1 new green jacket along with the 1 new pair of green pants. Multiply 3 by 2 and get 6, and then we multiply 3 by 1 to get 3, and then add these together to get 9. And if she were to buy 1 plum jacket with the 1 new pair of green pants, multiply 4 by 2 to get 8, and we multiply 2 green jackets by the 1 plum pants to get 2, add these together, we get 10. Then if she were to buy 1 new pair of plum pants along with the 1 new pair of green pants, then we multiply 3 plum jackets by 2 green pants to get 6, and we multiply 2 plum pants by 2 green jackets to get 4. We add these together and we get 10. So, as we can see, she could increase her chances the most if she were to buy 2 new green pants, if she could buy 2 new items of clothing. Like in Dana's case, before diving straight into seeing how she can maximize her combinations, if she could buy 4 new items, let's see what happens if she could buy 3 new items. So, since we know that she can maximize her options if she were to buy 2 green new pants if she could only buy 2 new items, let's start with that. So, if she were to buy those 2 green new pants along with 1 new plum jacket, she would have a total of 4 plum jackets and 3 green pants. So if we multiply these together, we get 4 times 3, which is 12. So that tells us the number of combinations she would have if she could wear a plum jacket with green pants. Then we multiply 1 by 2 to get 2, and then we add these together. 2 plus 12 is 14. Then, if she were to only buy 3 new pairs of green pants, she would have a total of 4 green pants, along with the 3 plum jackets. So 3 times 4 is 12, and 1 plum pants times 2 green jackets is 2. So 2 plus 12 is 14. Then, if she were to buy those 2 new green pants along with a new green jacket, she would have 3 outfits where she would be wearing a green jacket with plum pants, and 9 outfits where she would be wearing green pants with a plum jacket. So a total of 12 options for her. And if she were to buy 1 new pair of plum pants along with the 2 pairs of green pants, she would have a total of 9 outfits where she was wearing a plum jacket with green pants, and 4 outfits where she was wearing a plum pants with a green jacket. So 4 plus 9 is 13. So she would have 13 outfits in this case. So we have the greatest number of outfits if she were to buy the 2 green pants and the plum jacket, or only the 3 new green pants. So both of these answers are correct. Now that we know how Gina could maximize her options if she could buy 3 new items, we can now figure out how she can maximize her options if she could buy 4 new items. So, if she were to buy 2 new pairs of green pants, she would have a total of 3 pairs of green pants, and if she could buy 2 new plum jackets, she would have a total of 5 plum jackets. So 3 times 5 is 15. So she would have a total of 15 outfits with green pants and a plum jacket. And we still have the 1 times 2. And then if we add these together, 2 plus 15 is 17. So if she were to buy 4 new green pants, she would have a total of 5 green pants, and we multiply by the original number of plum jackets, so 3 times 5, we get 15. Plus the 2 when we have a green jacket and plum pants. That gives us a total of 17 outfits. However, if she were to buy 3 green pants along with 1 plum jacket, she would have a total of 4 green pants and 4 plum jackets. So we multiply 4 times 4, we get 16. And then we add that to the 2 with the number of outfits with plum pants and a green jacket. So we have a total of 18 options if she were to buy 3 green pants and 1 plum jacket. So in other words, she can maximize her options by buying 1 new plum jacket and 3 new green pants.